Hi, my name is Mark Parrish and I represent Turpin Sales and Marketing. We've put together a series of presentations called Machining Basics, which may help to attract people into the industry who have never thought of it before. This is the third in the series of the presentations and we'll be concentrating on tool holders primarily for turning operations. So why are Turpin Sales and Marketing putting these presentations together? Well, the machining industry is facing a massive problem right now in lots of ways, but specifically in the shortage of skilled machinists. So we put together a series of presentations which are very basic and they were developed with the intent to stimulate some interest from people who may want to come into this industry who've never considered it before. So who are Turpin Sales and Marketing? We're the leading manufacturer sales representative team in the metalworking industry in the Northeast. We represent superior products and have extensive knowledge in the metalworking industry that our customers have relied on for over 30 years. We are focused on cutting tools, work holding, tool holding, fluids for many industries, aerospace, firearms, medical and automotive. Through our technical expertise and selling skills, we provide the end user and distributor with increased productivity and profitability. This is achieved by assisting our distributors, end users, in presenting and implementing the quality products that we represent to the end user in a knowledgeable and professional manner. The metalworking industry is facing many challenges right now. Supply chain, material availability, but I believe the biggest one we're facing is the skills gap. So what is the skills gap and what can we do about it? The skills gap is basically a shortage of skilled labor in the manufacturing and machining industry. No one's going to trade school. No one's doing apprenticeships. Skilled labor is very difficult to find. It's predicted that 3.5 million manufacturing jobs will be unfulfilled in the next decade, which will be devastating for this industry. So what can we all do to improve this situation? Do you have existing employees that have an interest in manufacturing? Maybe you hire a person with mechanical aptitude, good work ethic, but no manufacturing skills. So what's the solution? Train your own. So Turpin Sales and Marketing have put together a very basic series of training presentations to help to inspire people who may want to know more about this industry and help to bridge the skills gap. Today we're going to cover tool holders, primarily lathe tool holders that fit into either a tool block or a turret block. As you can see in the picture, most of them are square shank, and we'll go into more detail on the next slide. The majority of tool holders for lathes that you'll find conform to two standards: ANSI, American National Standards Institute, which is inch-based, and ISO, International Organization for Standardization, which is metric-based. As you can see, there is a code, in this case MTFNR 164D. Every one of the letters and numbers means something. So once you see that code, you can identify exactly the major dimensions and which inserts fit into these tool holders. The first number, in this case the M, identifies how the insert is held in the pocket. If you look on the table on the right, the M stands for clamp and lock pin, which is depicted in the picture. There's A, C, D, P, S, W. The major ones that you will see are the M, which is the clamp and lock pin, and the P, which is the pin lock and lever lock, and the S, which is screw down. You can see that the ANSI and the ISO have exactly the same coding for this particular type. The second letter in the code, in this case T, again the same in both ANSI and ISO, depicts the shape of the insert. The T is a 60-degree triangle. The C is an 80-degree diamond. The D is a 55-degree diamond, and so on. So when you see that second letter, it automatically tells you the shape of the insert that will be held in that pocket. The third letter in the code, in this case F, which again is the same for ANSI and ISO, tells us the tool holder style. F on the chart on the right, you will see, is an offset shank with 0 degrees side end cutting angle. And you can see on the picture it's taken a triangle insert. The fourth letter in the code, in this case N, is for relief angle. There are several codes here, B, C, D, E, N, O, P. The N is negative or 0 clearance. The P is positive or 11 degrees clearance. The common ones you will see are C, N, and P. The positive and negative depicts how the insert will sit in the pocket and give you either a positive cutting angle or a negative cutting angle. Generally, the N or negative cutting angles are double-sided inserts, and generally the C and P or positive are single-sided inserts. The fifth letter in this code is the hand of the tool. Really simple. R depicts right hand, L depicts left hand, and N is neutral. Both the ANSI and ISO use the same letters within this position in the code. The next two positions in the nomenclature differ from ANSI to ISO. I'll take the ISO first, as it's more simple. You can see 25, 25. This is 25 millimeters by 25 millimeters. That's the size, the height and the width of the shank. So it is a 25 millimeter square shank. When we get to the ANSI, the first number describes the shank, the 16. That is based on 16ths of an inch. So 16 16ths of an inch is 1 inch. So that would be a 1 inch square shank. The next letter, the 4, actually describes the inscribed circle of the insert, and this is in 1/8 increments. So 4 1/8 is a ½ inch, so that would take a ½ inch IC insert. Again, I'll go over that. The 16 is 16 in increments of 1/16 of an inch, so that is a 1 inch square shank. And the 4 is in increments of 1/8 of an inch. So 4 1/8 of an inch is ½ an inch, and it takes a ½ inch IC insert. If you look at the ISO, the last letter there is a 12. That actually describes the inscribed circle for the ISO. So 12 is a 12 millimeter IC insert. The next position describes the length of the tool holder, and you can see ANSI and ISO come back together. So ANSI has a D, ISO has a K. If you look on the chart on the left, the K for the ISO is 125 millimeters length of the tool holder, and the D is 6 inches. So ISO and ANSI, that letter there controls the length of the shank. You'll see another number at the end there on the ISO, which is 12. That is the ISO insert inscribed circle, or 12 millimeters. So that concludes the nomenclature for both ANSI and ISO. So next time you're on the shop and you look at a square shank cutting tool, you can determine the major dimensions, the major clearance angles, which inserts it takes, all from reading the code. Thank you for taking the time to watch this short presentation. I hope you found it useful. There's more to come. But in the meantime, go to www.turpinsales.com or our YouTube channel, Turpin Sales. Thanks very much, and see you next time.